So we have, this should have been copied yesterday, if not feverishly copied now. A water tank is built in the shape of a circular cone with a height of 5 meters and a diameter of 6 meters at the top. So that is actually the shape of the cone, correct? It has a height of 5 meters and a diameter of 6 meters, which I'm actually going to need a radius, so it's going to be 3 meters. And you'll see why I need a radius instead of a diameter in a second. So that is the actual cone. It is a height of 5 and a radius or diameter of 6, radius of 3. Okay? Now here it says, so it's an inverted cone. They're filling it up and then the water comes out. So here it says, water is being pumped into the tank. So it's being pumped in, so that's positive. I'm getting more water. Correct? It's not coming out. At a rate of 1.6 meters cubed. Meters cubed is units for what? Volume. And minute is cubed for, or units for time. So we're going to have dV over dt, because our units help us to know what the heck they gave us. And it's increasing because they're pumping water into it at 1.6 meters cubed per minute. Okay? Find the rate at which the water level is rising. Water level rising, is that height or radius? Height. So they want the rate. So what are we asking us for? dH over dt. Find the height at which the water level is rising. So we're hoping it's a positive. When the water is 2 meters deep, what did they give me? Sorry? Initial height. Okay? So I separated them into information that's changing and information that's staying always the same. So this is staying the same over here. Why is it staying the same? Because that's the measurements of the cone, right? That's what it is. All right. So I have volume of a circular cone, correct? So that's the formula they'd have to give me on the actual test. It is, I think I copied it. Maybe I didn't. Yeah, I did. The volume of a cone is 1/3 pi r squared h. Now, what people will do is they say, okay, immediately I just take the derivative of that because I need dV over dt. There's a problem in this instance, and there might be a problem in your instances of your different related rates. You have to watch and see. So if I do this one, I would have to do product rule first off, because I have an r squared and I have an h, right? I have two variables. If I take the derivative of that, though, I'm going to have a dr over dt and a dh over dt. We agree? Do I have dr over dt and r to fill in? No. I would need the radius of the changing radius, correct? Do I have the changing radius? No, I have this stays the same radius. I have the radius and the height. Okay? So I need dr over dt and r over dt, which I can't, or r, sorry, and I don't have both of those. So if I go right away and I just do the derivative of that, I have a problem. I don't have information to fill in, and I can only have one unknown to solve, and that unknown is dh over dt. Correct? So this cylindrical cone one, or if you see this in a different one where they give you the actual shape, and this works mostly for a cone, and these come up all the time. What you can do is, you can do your ratio of what stays the same. So I can go r over h, or I can go h over r. It doesn't really matter. It doesn't have to be r over h. It could be h over r. The catch is that you have to make equals the same ratio on the other side. So because I have an r on the top, I need to put the radius first. So the radius is 3, and the height is 5. If I did h over r, I would just do 5 over 3. So you don't have to memorize it's r over h. It could be h over r. What you need to know is that the other side has to match. So if height's on the top, height has to be on top. If radius is on the bottom, radius. Okay. My problem is the r, correct? In this formula. I don't have dr over dt and I don't have r. This is a different r. I don't have the changing r and I don't have dr over dt. So if I can get this r to go away, my problem is gone. Correct? So what I do is I take this ratio and I solve for r so that I actually have r because I don't have it. So what I'm going to do, I'm going to cross multiply. So I'm going to go 5r equals 3h, and then I divide by 5. So r equals 3h over 5. Now, if I needed dr over dt, I would be replacing h, correct? You replace the one that you will need to go away. So I'm going to go to r, and I'm going to replace it with 3h over 5. So I go v equals 1/3 pi 3h over 5 squared times h, and then I'm just expand it so I can collect it, so I can have just h's. So I go 1/3 pi times 9h squared over 25 times h. And the 9 over 25 and the third can join each other. So you're going to get 9 over 75 pi, and then the h's can go together. What do you get? H cubed. Now, do I have any r's there? Now, if I differentiate this, do I have the right information? Yes, I'm going to need dv over dt, I'm going to need an h, and I'm going to need a dh over dt. I have an h, I have a dv over dt, I need to solve for dh over dt, we're going to be good. But if we would have differentiated before, we wouldn't have had enough information to solve it. So let's do the derivative of it now. So we have dv over dt, or 1, technically, because the derivative of v is 1. And then you have to follow behind with dv over dt, because you're doing implicit. The 3 joins the 9, so I'm going to get 27 over 75 pi h squared, and then what do I have to make sure to do? Multiply by dh over dt. So then I take the derivative of any variable with respect to time. Always have to follow behind with it. Correct? Now you can do this one of two ways. You can plug in right now and then isolate dh over dt, or some people like isolating dh over dt first, then plugging in. It doesn't matter, it gets you the same thing. So we could just isolate it by going 27 over 75 pi h squared. I'm doing this way because I've always done it the other way before, so I'm just proving a point. So dh over dt equals, now I can plug in. So dv over dt is 1.6 meters cubed per minute. Over 27 over 75 pi, and then h is 2 meters. And how do I know which h to use? It's always the one that follows in the question. So here it goes, find the rate at which the water level is rising as water is 2 meters deep. So this one here is the changing, right? It's like now it's 2 meters deep. It could get all the way to the filling it up the full way of 5 meters, but it's only 2 right now. So that's the one that you would use. The one in the question is the one that gets plugged into the derivative. So we're going to get, here we're going to get 4 meters squared and a meter cubed, correct? So I'm going to end up with meters over minutes, which is what I need. Height is meters, this is minutes. So I know I did well. Correct? Okay, so we're going to, it's a word problem, we can actually just get a decimal. So we go 1.6 divided by, let me do the bottom first, 27 divided by 75 times 5 times 4, and then 1.6 divided by that. dh over dt equals 0.354. Everyone get that? Meters per minute. Because this will become meters squared. This is meters cubed, they'll cancel. You get meters per minute. And we're happy because it's positive. And it's asking you how much, what rate is the height increasing at? Well, it's increasing at 0.354 meters per minute. Okay? So not too bad of a question if you know how to do the question. All right. Now we're going to move on to Rolle's theorem. Not exactly sure how these ones fit in this unit, but they put them into this unit, so we put it into the unit too. So I always just do them last. Rolle's theorem. So we have, let f be a function. The board is so wonky in this spot. I think it's my most written on spot, so it doesn't know what to do with itself. It just writes all curvy. Defined on a closed interval. It has to be defined on a closed interval, which means it has endpoints. If. Now remember when we did continuity, I said we had to show that the limit from the left and the limit from the right were the same, so the limit at that value was the same, and then f at that value was the same, and then it showed it was continuous. Or intermediate value theorem, you had to show not only that when you plugged the left part in and the right part in, one was below and one was above, but that wasn't just enough. You had to say also that the graph was continuous, so therefore they're connected and it's going to cross somewhere and make an x-intercept, correct? So there's all these stipulations of what you need. So in order to show intermediate value theorem, you have to plug the left closed interval in, right closed interval in, and see if one's above, one's below, and then state it's continuous, which was the part that everyone kept forgetting, to state it's continuous, because then that means that those two are connected. It's going to cross and make at least one x-intercept, right? So for Rolle's theorem, there's stipulations as well. It needs to be on a closed interval. Closed interval just means that you can have endpoints. So you'll have one left endpoint and one right endpoint, just like we did in intermediate value theorem. Okay? So that we have to have a closed interval. That's the first thing. Second, it has to, f is continuous, has to be continuous on AB. So you would have to state that, just like you were supposed to state it with intermediate value theorem, right? When I made you make that question up. Not only does it have to be continuous, it has to be differentiable from A to B. Well, if it's a polynomial, we know it's continuous and differentiable, right? So those are easy when they give you polynomials. Polynomials always make me happy. It has to be differentiable on A, B. And you don't differentiate the end values, that's why it's an open interval, right? And then the last thing is f of A. Remember when we did this, f of A had to be above or below, and f of B had to be above or below, and then we could do intermediate value theorem. That's how we did that one. This one, f of A has to equal f of B. So your y values of your endpoints have to be the same, right? So imagine it. If it was like a parabola, let's say. It could start here, it could do whatever it wants in the middle, and then it goes back up to that same height, correct? So the key thing for Rolle's theorem, and you're going to spot it, is that your y values of your two closed endpoints are the same, okay? So those are our three stipulations. So then we can say, if these stipulations are true, then there is at least one number C. I know C is a letter, but it's a variable, right? One number C in the open interval AB, for which f prime of C equals 0. We'll talk about that in a second. So with intermediate value theorem, we would say that if it followed the stipulation of one was below, one was above, there exists a C value that for which f of C is 0, right? There exists an x-intercept, correct? So they would say f of c equals 0, which is just a fancy way of saying there's an x-intercept. What is this a fancy way of saying? First derivative is equal to 0. A tangent is equal to 0. What does that mean? Whenever there's a tangent equal to 0, there's a horizontal tangent which exists. What exists on the original graph at a horizontal tangent? Max, min, sometimes a point of inflection. Correct? So basically they're saying if there is a closed interval from A to B, and if it's continuous and differentiable, and if that f of A equals f of B, there exists somewhere where there's going to be some sort of curve back up, which makes sense. If you have it, if it's continuous and it's differentiable, it's going to have to, and you have two heights that are the same, it's going to have to do something like this. It's going to have to come back to it. It can't do this. Why can't it do that? It'd just be a straight line. It wouldn't even be differentiable, right? That would kick out. It would be continuous, but it wouldn't be differentiable, so that's kicked out. So they're saying if there exists if there exists two y values that are the same, and you can't have a horizontal line because that wouldn't be differentiable, it's going to have to somehow curve back up. It could even have a few curves in there, right? It could do something like this, come back up. But there at least has to be one. That's what they're saying. There has to be at least one spot where you're going to have a max or a min. Something's happening, which makes sense. If you have two y values that are the same and that baby is continuous, it's going to have to somehow come back up and make some sort of max or min. That's all this is saying. Does that make sense? Okay. So that's why theorems work, because they're good for everything, but what you have to do is be able to just work through them and make them make sense to you instead of just looking at it and going, what is that person writing? Okay? Because you're going to get theorem over theorem over theorem in math classes in university. And proof over proof over proof. Okay. So, examples where it doesn't work. This is where Rolle's theorem does not work. You're going to tell me which of these bullets is why it doesn't work. Sometimes it's more than one. Sometimes it's just one bullet. So if one bullet doesn't work, like it's not differentiable, done. Right? Okay. So this is going to be my first example. So this is going to be my end A. This is going to be my B. Does f of A equal f of B? Does f of A equal f of B? Yeah, f of A, f of B. They equal. These are both closed. So, why is it off now? Stop drawing over there. F of A equals f of B. So that bullet's good. What bullet is not good? It's not continuous. In order to draw this graph, continuity, in order for it to be continuous, and this one has to have closed intervals, correct? So it has to be closed on both sides. So I have to have two closed dots. But in order to be continuous, you don't pick your pencil up when you draw the graph. So if at any point in time you have to pick your pencil up to keep drawing it, it's not continuous. So if I go to draw this graph, I went dot, pick my pencil up, open dot, shoot. It's not continuous, right? So this graph is not continuous. So that's what throws this one off. If it's not continuous, it's also not differentiable, right? That was the rule of differentiability. If your graph isn't continuous from that spot to that spot, it's not differentiable from that spot to that spot. Now remember, a graph cannot be continuous and still be differentiable. It would just be it would only be differentiable where it is continuous. So you can do pieces of it, it would be fine. Okay, let's look at the next one. What if I give you this? So this is A, this is B. Just keep getting served things. No. Okay, why does this one not pass? Not differentiable because there's what? A cusp. There's a point. So it's continuous, boom, boom, that's fine. F of A equals F of B, that's true. Has endpoints, good, good. It is not differentiable because of the cusp. Okay. Third example, you can probably figure out where it's going to go badly here because we have 3 bullets and I've through 2 of bad ones. Okay. What?
So f of a equals f of b just means they have the same y value?
Yeah. So here's A, here's B. Shocking. I don't think you saw this coming. So what's the problem with this one, Grant? Nothing?
That's complicated.
It's a complicated one. It's not, oh, sorry.
F-A.
Oh, you did know it. You played me. I didn't see that coming. Okay, so it is continuous from A to B. We agree? Therefore, it's differentiable because it's just like part of a polynomial. It's totally fine. Good. Doesn't have a cusp. But f of A does not equal f of B. This is true. So how do you spot Rolle's theorem? For the most part, when your f of A equals your f of B, that's going to be your like little like moment that's like, I remember seeing something about this. And then you'd be like, what was the theorem? I don't remember. But I believe you will. Okay. So here's an example. Example 1. Find the x-intercept. See, find, not determine. Who wants that? We're just going to find them. And then we're going to be done. So if we found them, no, we're not. Find the x-intercepts. It's in the book. I have just given up on writing determine. Of f of x equals x squared minus 5x plus 6. And show that why would they pick x-intercepts? Because their y values are the same. So they pick the x-intercepts as the endpoints, and they immediately know that your y values are the same, right? So it's a sneaky way of making them the same. And show that f prime of c equals 0 for some number c belonging to the interval formed by the 2 x-intercepts. And after you've done that, I have to write determine. Determine the value of c. It says find c. So what I want you to first do is just find the 2 x-intercepts. Okay? Once you find the 2 x-intercepts, you want to find where f prime of c equals 0. Correct? So how can you do that? Find the first derivative, plug in. Plug in. I don't want f prime of x equals 0. I want f prime of c equals 0. So I'm going to find the first derivative, plug c in for x and set it equal to 0 and solve. Okay? We find our x-intercepts by setting the original equal to 0. And we get x minus 2, x minus 3. So x equals 2 and x equals 3. So our closed interval is between 2 and 3. Right? Now, in order to show what c is, we have to explain the rest. Because f of x is a polynomial, or we could say is a quadratic, It is continuous and differentiable. Because if you don't explain that, that's great, you found a C, but you're not showing that Rolle's theorem actually works. You found a C. Yay, great. So because f of x is a quadratic, it is continuous and differentiable. There exists a number C for which f prime of C equals 0. And then we have to find it. So we're going to go f prime of x first is 2x minus 5. So we're finding f prime of C equals 2x minus 5. And then we know f prime of C is 0. That's a C. 2c minus 5. Oh, goodness. That's kind of funky. Equals 2c minus 5. Add your 5 over 5 equals 2c. D equals 5 over 2. Can you check this? Should you be able to walk away knowing if you're right or not? Yeah. Type the original in your calculator and look for this is a concave up, so it's going to be the x value of the minimum. Yeah. Which is 2.5, so we know we're right. So that's Rolle's theorem. The questions that would be for homework for this. So this is section 3.4. Nope, 4.3, I believe. I think I just went to opposite. Yep. Problem 9. AP practice problem 1. And then we have mean value theorem to go through. And yes, then tomorrow, it's optimization. Then we're done this unit. Then all we have left is integrals. It's reverse. Antiderivatives.
How long does that?
Mean value theorem. It'll look a lot like something else you've seen. So Rolle's theorem, I told you, the giveaway was when the y values are the same. The not so obvious way of asking it is giving you the two x-intercepts because it doesn't scream my y value is the same, but the y values are the same. Okay, that's how that one went. Mean value theorem. So we're going to let f be a function. Defined. And how you'll know to use mean value theorem is they'll say using mean value theorem. That's what they'll literally say. On a closed interval. Nope. Yep. On a closed interval. A, B, F. So intermediate value theorem, it was to prove that there was at least an x value, correct? An x-intercept, not an x value. Mean value theorem, what does mean mean?
Average.
Average. So we're going to find an average. When we did average value before, what did we have to use? The slope, correct? It's the exact same thing. We're going to be using the slope formula again. So mean value theorem means average. Average value theorem, or average value, we found that we used the slope. We're just going to be using the slope. But what stipulations do we need to have in order to use it? So it has to be continuous. The great thing about all of these theorems is it has to be continuous. So at least throw that into it if they ask you. And it's because it's continuous, because you need to be continuous for all of them. And shockingly, it's continuous on AB. It also has to be differentiable on open interval AB. So if I were someone, I would just throw that into a theorem at this point. It's continuous and differentiable. It's needed for all of them. So here it says, then there is at least one number c in the open interval AB for which, so there exists a C between AB for which f prime of C, so the first derivative slope, tangent slope at C, equals the slope between A and B. And I'll show you a graph so it actually makes sense. So here it says, if there's a continuous function between AB and it's differentiable between open AB, then there is at least one C where the derivative, the tangent slope at C is equal to the tangent slope between A and B. All right. So if I just drew a graph like this, so say that's my graph. You see it? So they're saying if AB is continuous and AB is differentiable, and at this point both of those exist, right? A is AB is continuous, open AB is differentiable. If I'm finding f of B minus f of A over B minus A, what am I literally just finding? The slope of AB, right? So I'm going to draw that. Awesome. Thanks for moving forward. Actually, it moved in a decent way this time, so we're hot. So, oh boy. Wasn't too bad. I'm in the bad spot of the board that curves, so who knows what's going to happen. So this is called a secant, not a tangent. Tangent slope touches in one point, correct? Secant slope just touches in two. I swear I turned that thing on. It's agreeing with me. Yes.
Windows is
Yeah. It's going through
Why do my remotes? Why do I have to touch the remote to the thing alert?
Needs to be taller.
See, this is where taller would be an advantage.
It is.
It's like I would have to be like 6'7". All right.
6'7".
Well, I guess when you're taller, you have longer arms because your arms are proportional to your body. Okay, most of the time. So secant slope is between AB. We agree? So all it's just saying is there exists a C value where you're going to have that same secant slope running somewhere, which you will, because there's going to be a point on this graph where you're going to have a tangent slope that runs at that same angle. Like for example, maybe here, you might have a tangent slope running. There's going to be a spot where you're going to have a tangent slope running at that line. That's all it's saying. We just need to find the C value where that exists. In this case, this would be the C value for that particular graph, right? So they're just saying there exists a C value where there is a tangent slope running at the same as the secant slope between AB. That's it. Walking over here saying, I want extra steps. I swear, indirectly, my brain's making me do that. Okay. So let's look at example 2. Example 1 was the Rolle's theorem. Example 2 is mean value theorem. Verify the function f of x equals x cubed minus 3x plus 5, where x is between -1 and 1. So I have closed interval, right, which I need. Is the graph continuous and differentiable between -1 and 1?
Yes.
Yeah, it's polynomial. Satisfies the conditions of the mean value theorem. So what are the conditions of the mean value theorem? Continuous and differentiable. So you can say and closed interval, right? Since f of x equals x cubed minus 3x plus 5 is cubic, is a cubic function. You could say a polynomial if you don't remember what it is. It still works. You're all polynomials. So if you're like, I think it's cubic, but I'm not sure for polynomial. Since f of x equals x cubed minus 3x plus 5 is a cubic function, I'll put polynomial in brackets. The graph is continuous and differentiable. The interval. And then the conditions of the mean value theorem are met. So if you're doing any of these theorems and you don't explain the conditions matter, you're not showing the theorem, right? You need those conditions. So that's why when you guys did the intermediate value theorem, a few of you did not for continuous, I couldn't give you full marks because you didn't actually prove the theorem. Okay, B. B wants you to find the numbers, and this comes up, this is like the AP question for mean value theorem that comes up all the time, this style. Find the number or numbers C guaranteed by the mean value theorem. So if I'm ever asked for the mean value theorem, I immediately write down the formula. It's never given to you. You have to memorize it. It's literally just slope formula with f prime of c, right? So we know f prime c. So there exists a tangent slope that equals the secant slope. That's all it is, right? The formula is, or the theorem is, there exists a tangent slope that equals the secant slope, correct? The tangent slope is represented by f prime of c. The secant slope is f of b minus f of a over b minus a, or just grade 10 slope, right? And then we just fill it in. We don't have anything right now. All we have is negative 1, 1, so we need to find some stuff, right? F prime of c we can do. What is f prime of x? It's 3x squared minus 3. But we don't want f prime of x, we want f prime of c. So we get 3c squared minus 3, right? So I can fill that into this side. 3c squared minus 3. Left side done. Right side, grade 10 math. Currently I have the x values, I need the y's. And I need f of negative 1, and I need f of 1, right? So, and you can put these backwards. You could do f of a minus f of b. You just have to make sure these ones are backwards, right? Whatever y you list first, you have to list its corresponding x first. We learned that in grade 10, that you don't have to, x1, y1 doesn't have to always be x1, y1. If this one could be x1, y1, this could be x2, y2. It doesn't matter. It just matters that whatever y value you pick first, its corresponding x has to come first. Okay? That's it. That's the only rule that you learned in grade 10. Because your teacher would have done, well, if you weren't online, your teacher would have showed you that you could take these 2 points to find the slope. You could reorder them, use these 2 points to get the same slope. Your just negative signs would be, or positive signs would be, and they balance each other out. Okay? You get the same answer. So let's plug it into the original. it's x cubed minus 3x plus 5. So we're going to get negative 1 cubed plus 3 times negative 1 plus 5, which is negative 1 minus 3 plus 5, which is? Negative 1 minus 3 is negative 4 plus 5 is 1. Now we'll plug in the 1. So we get 1 cubed plus 3 times 1 plus 5, which is?
I think that's wrong. I
It-
got,
It's minus.
I got 7.
Yeah.
It's minus, because negative 1.
Is this a
plus
negative
3
sign?
It's a negative.
Oh, look at that. There you are. I like when there's papers and you can see the whole paper in front of your face. I can't even see my equation. All right. Minus 3 times negative 1 plus 5. So it's 8 minus 1, which is 7. And then this one's going to be 1 cubed minus 3 times 1 plus 5, which is? My board is not writing in the right spot. Let's go over it, Henry. It's 3.
It's not nearly as bad as.
Oh, really? Well, it is when you try and go back over where you wrote. It's way off. Okay. So, if you use it how the actual formula is set, it's negative 1 to 1. So this would be my A, this would be my B. But you know slope-wise, it doesn't matter which point you actually put first, you're going to get the same slope. So don't get hung up on that part. But technically, we would do f of b, which is 3, minus f of a, which is 7, over 1 minus negative 1. Like I said, don't get hung up on it. Whatever y you pick first, just make sure you list its x first. Then it's other y, and then it's x that goes with it, right? That's what you just have to remember with slope. So we get 3c squared minus 3 equals negative 4 over 2, which is negative 2. Flipped, and then yes, negative 2. Okay, so then we just have to solve for c now. Add 3. 3c squared equals 1. Divide by 3. C squared equals a third. And like I told you, university isn't harder than this, it's just faster. Like, you just learn a week's worth in 2 days, right? So, just going faster. So you have to keep up and not freak out. Just keep up, and if you have to go home and make it make sense a little bit more in your head, that's fine. You'll be okay. You've learned these already, though, so you shouldn't have to. But the poor souls who didn't take help first, they go. It's hard. Plus or minus, so we get c equals positive or negative 1 over root 3, which they could actually give us as root 3 over 3, the rationalized version. Either one's acceptable in a written response, they don't care. So there are actually 2 numbers, right? So I want you to type the original into your calculator, please. Y equals, what was it again? X cubed minus 3x plus 5. And we don't want to look at the whole thing. We want to restrict it between negative 1 and 1, right? I'm going to go to my window, and I'm going to make this be negative 1 and 1. Okay? I know that at 1 over root 3, so if I go second trace value, 1 divided by root 3 was one of my answers. It's me the right one. It's over here. It's saying that there's a tangent slope here. So if I connect these, if I connect those two, this would run at the same tangent slope, which if this was drawn better than what I just did, it looks like it works, right? If I try the other one, negative 1 divided by here. Oh my gosh, I can't draw straight if my life depended on it. But they run the same, right? So they run at the same tangent slope. Those are the 2 points. Okay? Tangent slope. Let's think about it. So we know the tangent slope is what? The first derivative, correct? We know the secant slope of those two is 2. Oh, no, it's -2. That's the secant it'll catch up. That's the secant slope of that, correct? Can we not find the tangent slope using our calculator at those points and see if it's -2? Yeah, how do you find the tangent slope? dy dx. So let's try it out. We can check these. So I still type my original in, like I have, and then I go second, trace, 6. And now I'm going to put in -1 divided by √3. And what's my dy dx? -2. Oh, I'm a genius. Okay, let's try it again. Second trace, 6. 1 divided by √3. And it's -2. We know we're right. We walk off, we are brilliant. We got our 2c values, right? So a lot of these, if it's in a calculator section, you can check stuff. If your prof lets you have a calculator, you can check stuff. Only catch is your midterms are often written in your 50-minute class or your 80-minute class. So you write really fast.